Greetings, I am Nima Hong. Today, I'll be presenting my final project, Cloud Prophet. A cloud-powered time series forecasting, we aim to transform energy demand forecasting with advanced cloud technology. Malaysian government has a grand ambitions on setting the targets for renewable energy capacity to achieve 70% by 2050. It is estimated to be 637 billion ringgit by 2050, which will be used to establish new solar infrastructures, integrate into existing power grids, and expand the existing grid infrastructure. Hence, forecast the increasing energy demand becomes the key. As you can see, this graph shows that Malaysia has increasing energy demand year by year. Here are the three problems Cloud Prophet aimed to solve. First is the outdated forecasting models, which they didn't incorporate external factors such as weather conditions and holidays, hence the lack of accuracy and reliability on the predictions. Second is the on-premise servers for storage, so this causes the data accessibility across different government agencies. Third would be the bureaucratic hurdles, which cause time-consuming data access, which slow down the data-driven insights. Cloud Prophet is developed with three objectives in mind. First is to build a machine learning forecasting model by leveraging multiple data sources including weather conditions, holidays, and other data. Second is to utilize secure cloud services for scalability and reliability, which will replace the obsolete on-prem servers. Third will be develop an end-to-end energy demand forecasting system that covers an entire process from automated daily data ingestions to web applications with interactive visualizations for forecasted energy demand insight. Cloud Prophet is proposed to revolutionize Malaysia's energy forecasting with advanced machine learning algorithms and cloud-based data integrations. This enhances overall accuracy, security, and accessibility. This is packaged as a whole web solution which streamlines the whole energy demand planning process for Malaysia energy sector. Cloud Prophet has four system modules. The first module is the energy demand forecast, which has the energy demand forecast generation via the different algorithms and holiday and weather data integrations. Module 2 covers the scalable cloud services, which include the historical data extractions, daily data ingestions, data storage and data warehouse, data processing pipeline, and model hosting. Module 3 would relate to the end-to-end forecasting system, which consists of the automated forecasting pipeline, energy demand dashboards, interactive visualizations, and trend analysis. The final module, which is the user access management, consists of the administrator panel and also the insight sharing mechanism. This is the end-to-end system architecture for Cloud Prophet. We have three main data sources, which are energy, weather, and holiday. We will use Azure functions to call the API and extract the data daily, and we will use notebooks to copy the data from the Python library into our storage. As for our storage, we will use Azure Data Lake Storage Tool as the main staging area for raw data. Next, we will have the Azure Synapse Serverless SQL Pool as our data lake, which will be storing all the transformed data. We will also use Azure Synapse Pipelines to manage all the daily running pipelines. Next, for the model training, we will be utilizing Azure Machine Learning, where we have deployed XGBoost and tested other models as well. We will use Azure Container Instances to deploy the model, and we will run it as batch inferencing, which will be predicting the energy demand for the next 2 weeks for each day. We will have a scheduled pipeline job, which will be running at a specific time daily to update the data and generate the forecast. In the front-end side, we will use Next.js as the front-end web applications, and we will have the Power BI embedded as the interactive visualizations. This is the data pipeline for Cloud Prophet, which will be running daily. The data extracted are actually updated to yesterday, so we will use the Azure Synapse pipeline to manage different Azure functions, which will be running at 1 p.m. every day. We will upload the data as Bucket file, which will be stored in the Azure Data Lake Storage Tool. Next, we'll be having the Azure Synapse Serverless SQL Pool, where we'll be storing all the tables. So external tables are like SQL tables, except that they're queried directly from the Azure Data Lake Storage. And Transform will store the transform tables that we will be using for machine learning and also for visualizations. For model inferencing, we will be importing the data as ML table and having an inference pipeline that runs at 1:05 p.m. every day and upload the data back to the Azure Data Lake Storage tool. And every day at 1:30 p.m., it will refresh the data and import the data as Power BI datasets and show at the application layer. Cloud offers three major benefits. First is to offer reliability through accurate energy forecasts. Second is to increase the efficiency by reduce the operational costs and infrastructure investment. Third would be alignment with the national policies such as National Energy Transition Roadmap and a Renewable Energy Strategic Development Roadmap. Cloud Profit aims to reduce the investment cost by at least 1% through modernizing the whole energy infrastructure planning. It is approximate to around 6 billion ringgit by 2050. Cloud Profit is targeted towards government agencies, which the system is easily integratable into the energy system pipelines if the Malaysia Data API becomes available. It is to support the primary objective of obtaining the energy demand insights for infrastructure planning. Now we are moving into the project demo for Cloud Profit. First, you will land on the homepage, which will find all the details about Cloud Profit, including problem statements, the main system objectives, the system modules overview, and target audience that we aim to serve. Now we will log in to the Cloud Profit, but first we can create a new account. Say new user at gmail.com and password and register. So new account is registered. However, this account is not loginable as it is not currently active. But first we will log in into the admin account. When you are logged in, you will bring to the home page for the Cloud Profit, which will be showing you the Energy Insight dashboards. And you can have different tabs for different dashboards as well. And the users is for admins only. Now we will be moving into the module 1. For module 1, the user can access the generated forecast through this tab. For the latest updated on 14 June of data, the forecast generated should be 14 days ahead, which is around 29 of June. And the users can compare the performance among different models. For information, XGBoost is chosen as the best model and still currently using till this day. Other models like RSTM, Profit, Arimax are experimented from 1st of March until 30th of April and found out that they are not suitable and perform worse than XGBoost. In this tab, the user can also compare the performance among the different models. The main metrics that we utilize is root mean square error. As you can see, XGBoost is the lowest among all of the models. For the forecast data, we have utilized holiday and weather data, which you can see here as well. As you can see, there's an increasing trend for the energy load, which is correlated with the temperature features here. For the forecast data, we have stored them as data asset inside of Azure Machine Learning. As you can see here, it's stored as ML table, and the type of tables that you can expect is like this, which include the date, zone name, energy, weather data, and also the holiday data. For module 2, we focus on the provision of Azure Cloud Services. So this is the sample resources that we have deployed, and this is the proof of the resource actually run for the past months. So this is the Azure Data Lake storage. So we use this to store all the historical data and forecast data. For example, if we go to energy data, we can see the latest data is updated here. So this is stored in the bucket format and in the hierarchical method. And for data lake, we use Azure Synapse Serverless SQL Pool, which you can see there are tables created and the views created here. If we run the query, the data can be queried directly from here. And we also created serverless functions, which will be triggered to extract the data from the API, which you can see here based on the logs. And we use Azure Synapse pipelines to manage all of the Azure functions, and we will be run at certain times for every day. And we also host the models here directly inside of Azure Machine Learning Studio. For module 3, we have prepared an automated forecasting pipelines, which will be running at 1:05 PM every day. As you can see here, the job runs successfully daily. We also prepare an energy demand dashboards for the users to interact with. For example, the users can interact with the date filters, the users can interact with the zone filters, and the users can interact with other visuals as well. We also prepare a different analysis the users to do their energy demand planning. For example, the users can see the year-on-year energy demand growth and by zone, and the impact of weather conditions on the energy load, and together with the holiday impact and the weekend impact. As you can see, holiday has a higher energy impact, but for weekend reduce the energy load. As for seasonalities, the users can also check for different date features how the energy load changes. For example, in weekdays, you can see that Saturday and Sunday has a lower average daily energy compared to other days. For Module 4, for admin, they can access the user list in this tab, they can search for the users, and they can toggle the user status and also the access level, for example here. By default, when the new user registers, they are inactive and also only have view-only access. Hence, the admin need to log in and activate the accounts. To demonstrate, we will use the testuser@gmail.com and steven@gmail.com. The user is inactive. For view-only access, the users can only interact with the dashboards without accessing to any buttons that is available here. For insight sharing, the users can use these buttons to share the insights with other users. For example, if they want to extract the data from the visuals, they can go here and export as Excel. As you can see, the underlying data is here. The users can also export the reports as PDF file. The users can also use Quick View to jump to different filters that is previously saved. And they can also create a new view for their own uses as well. For example, if we go to trend analysis and we highlight these 3 zones and we highlight this data and we save. If we go back to other views, we will find the one that we have saved previously. The users can also share it with other users through copy-paste the link here. Let's say if you log into another user account, and we will pasting the link here. In conclusion, Cloud Prophet vision is to transform the energy demand forecasting for Malaysia government agency using cloud-based end-to-end machine learning forecasting system. In the end, we have managed to solve all of the problem statements, achieve all system objectives, complete all system modules, and we successfully utilize Azure Cloud Services and develop using the Next.js framework together with the Power BI embedded for interactive visualizations. Thank you for your time and attention. Have a great day.